righty. All those wonderful people are playing along at home. Class, Faye, hi. All right, all the people at home, everyone say hi to Faye. Okay, good. All right, so yeah, this is. I had to get this recorded. She's in a good mood today, so therefore, yes, I know it's a rare occasion. All right, so we're gonna do properties of definite integral. So these properties, definite integral, work with mean value theorem for integrals, find the average value of a function, interpret integrals involving rectilinear motion. That means moving backwards and forward. Okay, properties 1 through 4 in this section require that a function be integratable. So it has to also be integratable for this. 5.2, two theorems guarantee function is integratable. Function that is continuous on a closed interval is integratable over a to b. Function that is bounded on a closed interval from a to b and has at most a finite number of discontinuities from a to b is integratable on a to b. So that means you can have a removable discontinuity on these. So two functions are integratable, f and g, closed interval, then, so you could just take the two functions and do them separately. We are going to actually get into something like this, especially with the negative and positive for these right here. So, okay, Faye, have you taken physics? Okay, so one of the concepts in physics has to do with velocity. Okay, so let's say I'm gonna walk from here to Douche Bros. Okay, so I'm going a positive distance that way, but then I'm coming backwards this way. So I walk backwards back to this exact same spot. So yes, there we go. There we go. Yes, and that's where this comes into play. So we're going to have to actually look to see the total distance covered, because a negative velocity means I'm going in the opposite direction, and we're actually taking integration of velocity to get where my position is. All right, so you ready? All right, so we're going to do this one right here. So I'm gonna break it up into two separate parts. So this is going to be the integration from 0 to 1 of x squared dx minus the integration from 0 to 1 of e to the x dx. Simple, right? Okay, so let's integrate x squared. So that's going to give me x to the it's the opposite of derivative, right? No, that's derivative, right? Derivative, the exponent goes out front, right? Yeah. And then I subtract 1 from the exponent. Yeah. So integration is the opposite, so instead of going out front and subtracting 1 from the exponent, I'm going to take care of the exponent first. So this one's going to be x to the third, and instead of multiplying by the exponent, divide. There we go. Alright, so, and I know we don't have earbuds in right now, because this is me and you having a conversation going through these, right? And derivative of e to the x is the same as integration of e to the x, which is, Faye, what's the derivative of e to the x? E to the x. Okay, and so therefore, if the derivative of e to the x is e to the x, what's the integration of e to the x? E to the x. From 0 to 1. Okay, so let's go ahead and do this one and evaluate it. So top minus bottom. So that's going to be 1 to the third over 3 minus the bottom evaluate it, 0 to the third over 3. That's this one right here, right? Subtract this whole thing, so that is going to be e to the first minus the bottom, e to the 0. Okay, so this is going to give me 1/3, right?
You don't have to do the dividing thing on the e.
I almost heard what you said.
You don't have to do the dividing thing on the e.
No. Nope. Because the derivative of e to the x is e to the x, right? So if you think about the derivative and antiderivative, integration is just antiderivative. So if e to the x derivative gives me e to the x, so if I start with the derivative of e to the x and work backwards, my integration is e to the x, yeah. Alright, so this is going to give me 1/3, so minus 0, right? Okay, minus e to the first power, and anything to the 0 power is 1. And then I distribute. Come on. And I distribute here. So it's going to change some signs. So this is going to become a negative, and this one's now going to be a positive, right? And so I get a positive 1/3, and a positive 1 is a positive 4/3, right? So my answer is negative e to the first plus 4/3. Hey, Christian. Yeah. I thought I already gave them to you, but that's fine. I'm pretty sure there's one person that is supposed to be in this class that is not going to show up. There's one person that just never shows up.
Oh, she'll show up for the last two.
What the fuck?
When's the test for the senior?
I don't know. I'm trying to work around the testing schedule for the, like, all the standardized state testing. Like yesterday's I day. I'm gonna be gone on Friday. I think there's some more, something next week. Yeah, like weird schedules. And so I'm trying to finish as soon as I can.
Oh.
But we are, so like that guy right there, he's doing AP test practice now. So once we get to the point where you feel comfortable with the homework, I could give you a test practice every single time. So if you come to class, or you come in for advisory, I'll give you a test practice.
Yes.
Okay. Does that make sense? Yes? Christian? Yeah? Good? Okay. Alright, integral of constant times a function. You could actually factor out that constant. So if it is a constant factor, I could actually take it outside of the integration. It makes your integrating a lot easier. A lot easier. So this one right here, all right, Christian, what would my constant here be?
Your constant be.
You're taking it out of the function, not of the bounds.
So the constant would be 3.
Yeah, it'd be 3. So I rewrite this as 3.
Oh shit.
Okay. So, and the integration of 1 over x,
Is
ln x. So right here, it's important. So 3 is the ln of x, right? And that is from 1 to e. Then evaluate it. And just so you know, this slight thing right here, when you take integration, put absolute value bounds because we know it does not exist to the left of 0, right?
Right.
So it has to be it's weird because especially on like the free response, if you get one of those weird questions and it asks you to integrate something like this and you get that, you have to show absolute value bounds, especially if it's like a plus C type problem. So on this one right here, it wouldn't matter because you have bounds here that is going to be from here to here, positive, right? So yeah.
One more
And-
time.
Huh?
One more time.
Okay, so you ready? Absolute value bars. The domain of ln x is all positive, right? It doesn't exist in the negative, right? So absolute value here, okay, for any of the problems that you have that have plus C. This one right here for the bounds, it's not gonna matter. Does that make sense? Okay. Alright, so let's do that one. So ln x, I'm sorry, ln e, what is ln e?
We would have to use substitution for that. Or would it just be LNE? Wait, 1 over E.
Nope, ln e, 1, it's 1. Because ln and e are opposite of each other. Just like log base 10, log is base 10, right?
Right.
Right? Log is base 10. ln is base e. So if you have log base 10 of 10, okay, so yeah, that we're gonna get 1 off of that. Yes. Yes, we're just gonna have tree in there doing it all. See what I did there? It was supposed to be funny. Dishwasher. Put on ting.
Does tree wash dishes?
No.
He
But
he
yeah,
wash
no,
dishes
yeah.
at his job.
A dishwasher. Anyway, fine.
So funny. It's not funny.
Anyway, alright. I'll stick to my day job. Alright, so it's gonna be 3 times 1. And what is ln 1?
Stop.
What is ln 1?
Let's look at nature.
ln 1 is 0. If you remember the graph of ln, goes like this, and right here at 1 it's 0.
Oh, yeah.
Okay, so that's going to be minus 0. So my answer is just 3. Are you okay, Christian?
It's pretty funny math.
The nature.
It's not even funny, you're just laughing.
So,
I got 3 hours of sleep, so everything is
dude,
really
I
funny
have
right
no
now.
idea how that was funny.
Okay, it's not funny anymore. Continue.
You know, I met Bobby Yang. Wait, who's that one Asian comedian?
Huh.
No, not the guy who plays that one guy who I gotta think of.
On that podcast with that like elderly looking dude?
Yeah. him,
Wow,
him.
wow, you just like, yeah.
I met that guy.
You have?
You met Uncle Roger?
Oh,
Oh, the Asian comedian. Is there
Yeah.
more than one?
Oh yeah, obviously.
Okay.
Wrap it up.
They can
Yeah.
do everything.
Yeah.
Okay.
We got that.
Okay.
Actually,
Anyway. Alright. We can do a lot with this one. I'm gonna use a couple different things though. I don't like the fact it's being divided. So I'm gonna break up everything individually.
Segregation.
To what?
Segregation.
Segregation, yes.
Oh my
So, I don't like the 2 in the bottom, so where am I gonna put the 2?
The rest of the twos.
Send it to infinity and beyond right now.
Cancel it out.
How about up front?
Multiply it.
Yes, 2
How about
could
the
be a con,
inclusive and
could be, what?
How about the inclusive and consider?
I'm not inclusive.
You're canceled. You're
Yes,
canceled.
I'm
Just like
exclusive.
M&M, you're canceled. It's over.
I wanna get that 2 out of the bottom. So I'm gonna take it out front. What would I take it out front as? Yeah, 1/2. Because the 2's in the bottom, it would be 1/2. Then from 1 to 2. And then I'm gonna take each item and divide it by x. Each term I could divide by x. So that's gonna give me 3x squared minus 6x minus 5 plus 4 over x. Now I can do each one individually.
Hip hip hooray. Nothing.
Oh wait, nope.
Remember on TikTok seeing those like Arabic convenience store mukbangs?
So 3 x to the x to the
3x to the second plate.
third, right? Adding an exponent,
Oh, you're doing that.
integration, and then divide by 3. There we go. Minus
6x to the not 2 divided by.
Yep. Next one is gonna be
5 divided by 1. Oh no.
yeah,
Yeah.
yeah, that's fine. Okay, if that helps you. And then 4 divided by x.
4 to the positive x.
No.
Wait.
Isn't that just 1 over x?
Yeah.
What's integration of 1 over x? ln x. So this is gonna be plus 4 ln of x, and that is gonna be from 1 to 2.
Watch out. Is the absolute value gonna be necessary to use on the AP?
No, I'm doing it for, like, we just talked about that a minute ago. Any of the ones, I just try to get in a good habit of whenever I integrate, I always put that there. Because any of the problems that you're gonna have, that would be, if this was just, there was no bounds on here, it would be like 4 ln of x plus c. This would be a correct answer. This would not. So, correct, incorrect on the AP exam.
Okay.
So yes, we do understand what it is, that we know, like, there is a restriction on ln, but we need to actually put it there, especially with the plus c. I try to keep it as a habit to always put that absolute value bar. So, like this conversation we're having right now is perfect for this. So, yeah, just to make sure that it is always written, because I don't want you to get it wrong just because you got lazy. Alright, so let's go ahead and do, alright, so let's start plugging in. So I have 1/2, and that's gonna give me, let me see, those cancel, and that's gonna give me 2 to the 3rd power is 8, minus 4 times 3 is 12, minus 10, minus my lower bound, which is going to be 1/3 minus 3 minus 5. Oh wait, I didn't do the ln, did I? I got distracted. Let me see, that was 12, 10, and then plus 4 ln of 2, and then the lower bound was 1/3 minus 3 minus 5 plus 0. Because ln1 is going to give me 0 times the 4 is just 0.
So is the first one 1/3?
Huh?
Is the first one 1/3?
Plug in 1 into this. Oh, it's.
But yeah,
It should be just 1, right?
Yeah.
Oh, thank you. Man. William. Good job. Give yourself a high five. Where are you at on that one, Tree? Okay, I know. So I erased too much. Minus 3.
Wait.
There you go.
I see. I understand.
Okay, so on the left-hand side, what do we get? That's gonna give me, negative 14. Plus 4 ln of 2 minus the lower bound, which is gonna give me negative 8, negative 7, and then, so that's the reason why I keep this in parentheses right here, because this subtraction of my lower bound is always gonna get me here. That's where, if there's a mistake that you're gonna make by texting during my lesson, while I'm trying to get you to pass, right here, this is where it's gonna be. Forgetting about that negative and distributing it to everything over here. So change that to positive, so that would give me negative 7 plus 4 ln2.
Good enough.
Or do we just leave the 1/2 as a coefficient, or do we do that? Like
Thank you. It's not just a coefficient, okay? I could leave that as an answer, but I left off that 1/2. So I could actually have all this divided by 2. Because that coefficient out there, you can't leave it alone. You always got to keep track of all your stuff. So even though we factored it out over here, we still have to account for it down in our answer. Even if I just said 1/2 times this answer, that would still be, that would be correct. You could just leave it out, or anything else you could factor. Any other question? I think that's it for today, because I'm gonna have you guys, yeah. So, I'm going to stop right here, and I'm gonna have you people work on homework, and that should be it. Make sure you like, share, and subscribe.